nucleophilic substitution reactions. Okay, so please write nucleophilic substitution reaction. Now, what happens in this reaction? So basically, we have haloalkene, and if you look at the nature of haloalkene, don't write anything right now. If you look at the nature of haloalkene, this halogen atom is more electronegative. That is why it is going to pull electrons from the alkyl group, making it delta negative, and the alkyl group will be delta positive. Okay, so whatever carbon it is bonded to, so let me write it like this. We have R, CH2, and X. Okay, so I'm showing that carbon atom. So the alpha carbon I'm showing here. So if the X atom is pulling electrons, it will be delta negative, and this carbon atom will be delta positive. Okay, no matter what this carbon atom it is, whether it is 1 degree, 2 degree, or 3 degree, you are going to get attacked with a nucleophile. So nucleophile is negatively charged, and this carbon is delta positive. Now what can happen is nucleophile replaces this halogen atom. So you'll have R, CH2 bonded to nucleophile. So basically, this reaction happens in nucleophilic substitution reaction. Please write a reaction in which, so it is a replacement reaction now. The halogen atom is being replaced by a nucleophile. Now, what is a nucleophile? We will see. A reaction in which a group of substrate is replaced by a nucleophile is called nucleophilic substitution reaction, and it is denoted by SN. Some basic definitions, please write. Substrate. So in this case, substrate, we are going to take haloalkene, but substrate is any organic reactant molecule. Okay. So what is substrate? Any organic reactant molecule. And then we have nucleophile. So what is nucleophile? Nucleophile is made up of two words, nucleo, which means nucleus, And if you remember what charge it is in nucleus, so nucleus, these are positively charged because of the presence of electrons. You have nucleo, and then we have phile. So the meaning of phile is loving. So this means that these are nucleus loving. That means these are positively charged loving. So they love positive charge. Okay. So nucleus is positively charged and they love positive charge. So obviously they are going to be negatively charged or electron rich. Okay. So these are what? Electron rich species. That attack on carbon atom. That attack on carbon atom. Please write this down. How does you will write next point? In SN. In SN. Also, nucleophile is shown as Nu. In SN, nucleophile, and I put up a negative sign always showing that nucleophiles are negatively charged or they have electron richness. In SN, what happens? Nucleophile replaces the halogen atom. The halogen atom. And the halogen atom is called leaving group. Is called leaving group. So just a simple question. Identify the nucleophile and leaving group. Okay? Identify the nucleophile and leaving group in following. Here we have iodine, and here we are using KCN. Oh, sorry. My bad. Here you won't have NO2. Here you will have, let us suppose what, chlorine. So you get AgCl. So please, you have to identify what is a nucleophile in the following and what is the leaving group in the following. Start answering. I will give you guys 2 minutes. All of you understood the question, yes or no? Deborah, Fia, Hafsa, Khatun, and Rabah. Yeah, Fia, water. Okay. Yes, very good, Fia. And the leaving group. No, 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 no. Halogen atom is the leaving group, no? It replaces the halogen atom. So you have to identify what it replaced. You have identified the nucleophile very correctly. Yeah, correct now, it's fine. Yes, Rabah, correct. Yes, Mariam Khatun, correct. Yeah, here your now answers fine, correct, very good. Hafsa, what about you? Hafsa, I did not get any answers from you. Hafsa, am I audible?
Yes, sir.
Yes. So I did not get any answers from you. Please send your answers.
Okay, sir.
Yes, correct. Yes, very good. Correct, Hafsa. So most of you have answered it correctly. Now, moving on, let us analyze the nucleophilic reaction. Okay, so please don't write anything, just listen. So we have our X bond. Don't write anything, please listen very carefully. And we have nucleophile. And what is happening? The alkyl group is making bond with nucleophile and the halogen atom is leaving as halide, right? So in all the above cases, it is Cl negative, I negative, and Br negative that is attached with sodium positive, K positive, and Ag positive. Okay, so it is actually the halide ion, right, which leaves. Halide ion which leaves. But I'm not going to talk very much about the halide ion, but rather I want to know what is happening in this reaction with respect to bond breaking and bond forming. So what I can see here is that Rx bond, this is being broken. So Rx bond is being broken. And this is a new bond, R mu, RNU, that means R with nucleophile, this is being formed. There are two things happen. That means what I can say that there are two things happening. What is happening? First of all, Rx bond breaks, and RNU bond forms. Now, we have two things happening. The Rx bond breaks and RNU bond forms. Now, there are only two possibilities. Now, what can happen? Both of them can happen in a single step. Okay. Or they can happen in two different steps. Okay. So single step, it can happen in a single step, or it can happen in 2 steps. Right? There are 2 things happening. So both the things can happen simultaneously. While the Rx bond is breaking, the RNU bond is getting formed. Or the other case, Rx bond breaks completely, and then the nucleophile attacks, and then RNU bond is. So there are 2 things, 2 ways in which a nucleophilic substitution reaction can happen. Now, if we are going to write the types of SN, so there are 2 types of SN, please write. Types of SN. Meaning nucleophilic substitution. There are 2 types of SN. One is known as SN1. And the other one is known as SN2. And please remember, this is what? This is nucleophilic substitution, unimolecular and bimolecular. It is not talking about steps now. Okay. So the thing is that we don't mean the classification mainly is because the types are because it can happen in 2 different ways. And those ways they just differ in the number, they differ in the number of steps. But number of step is not a chemically right term in order to divide 2 things. Okay. So we derive the name from a different thing. So what is that thing? We will come to know. But please write first of all. Types of SN, SN1 and SN2. Right here, SN1. It refers to unimolecular nucleophilic substitution. Okay, so 1 is for unimolecular. Write the next point. What does this mean? It means the reaction in which rate depends on the concentration of substrate that is haloalkene in this chapter. Concentration of substrate only is known as SN1. Now, in this case, what is happening? The rate depends on, that means the rate of reaction is directly proportional to only what? The concentration of nucleophile. Sorry, concentration of the substrate. Just a second, guys. Sorry. Okay, so rate depends only on the concentration of substrate. And in order to remove this proportionality sign, I can write rate is equal to K into the concentration of Rx, the haloalkene. Right? Now, in this case, the order is equal to 1. And the molecularity is also equal to 1. Now, order and molecularity, you will be having good idea about it once we are done. Once we are done with chemical kinetics.
Sir.
Yes, Rami.
Sir, order is equal to 1 and molecularity.
Yeah, molecularity is also equal to 1.
Sorry, sir.
Yes, molecularity is also equal to 1.
Okay, sir.
Write this down. Let me know once you're done. Okay. Now please write the mechanism. So SN1, it occurs in 2 steps. Number 1 is, first the breaking of CX bond happens. Now please see. We have carbon atom. And here we have halogen like this. And then we have 3 different groups attached to it. Let's suppose we have 1, 2, and 3. Now, here what's going to happen? This X bond is going to break. First of all, that means CX bond breaks. And this is a very slow step because obviously bond breaking is taking place. Now, after we have, you see that electrons are moving to halogen atom. Okay. And that is why this carbon atom will get a positive charge. And it will become a carbocation. 1, 2, and 3. Okay, just and this is a carbocation. Just give me a minute. There's a parcel I have to take. Okay, please write. I will be back in 2 minutes. I'm sorry, guys, I have to leave for a while. Okay. So this is a carbocation. Once this bond breaks, and this is a very slow step because bond breaking is happening. And that is why this is also known as, this step is also known as formation of carbocation. Formation of carbocation. Okay. Now next step is the formation of C-NU bond, or we call this attack of nucleophile. Attack of nucleophile. Now please remember, if you guys remember, this is what carbon atom with 3 bonds, so it will be sp2 hybridized. And if you know carbon is 1s2, 2s2, 2p2. Carbon has 2s and then 2p, right? So here we have 2 electrons and here we have 2 electrons. In excited state, what happens? This carbon atom is having electrons in all of the 4 carbon atoms, right? Or sorry, of the 4 orbitals. They mix together and form sp. They mix together and they form sp3 hybridization. But since it is having a positive charge, that means it has lost an electron. So this electron will not be there, and it will be only forming 3 hybrid orbitals. That will be sp2. And this will be a vacant p orbital. That is a pure p. Pure p orbital, it's going to be vacant. Is this clear? Yes or no? Please tell me. Are you clear about the vacant pure p orbital and the sp2 hybridization, guys?
Sir, since it is vacant, it will be pure.
Yeah, since it is vacant, it is not going to take part in hybridization. In hybridization, only 3 orbitals are taking part, sp2, right? S and p2, 2 p orbitals. One of the p orbitals is going to be vacant.
Okay,
Got this?
sir.
Okay.
Yes.
Now please see here. So I can write the carbon with 3 of its bond. We don't know, 1, 2, and 3 groups are attached here. And this carbon atom will be having a pure p orbital like this, which is going to be vacant. Make a bit of big C. One second. This is the vacant pure p orbital of carbon atom, and here are the second and third groups attached. Third, and this is the second. Now, when the nucleophile comes, the nucleophile, it has options. A nucleophile can attack onto this orbital also. From this lobe particularly, orbital is only 1, but from this lobe, or it can do an attack onto this lobe. Okay, so it can attack both the ways. So 50-50 chances are there that it can attack on this part, and it can also attack from this red pathway. So we have red and green 2 pathways. So let us first of all look, if we have the green pathway, what is the product? So if we are on a green pathway,
2 lobes.
oh, p orbital is like this, right? P orbitals.
Okay, so we are dividing and writing.
No, not dividing. I cannot write carbon atom in between like this, no? Got it? So I'm just showing the orbitals and also the carbon atom. Got it, Fia? We are not dividing it.
Sir, I don't understand.
Yeah, so it is actually like this. I mean, if you zoom into the carbon atom, there will be no C. Correct. It is actually, but we have to represent that there is carbon atom here. In the reality, I mean, you will not see the letter C in the carbon atom, right? But we have to denote it. That's why you just have to break it.
Okay,
so in the green pathway, what's going to happen? In the green pathway, I will have carbon atom like this, right? And 1, 2, 3 will be behind now. 1, 2, and 3 groups. Because we have attached here, this nucleophile will be attached this way. And if I go towards the red pathway, the carbon atom will be like this. The nucleophile is attacking from the back side, and the 1, 2, 3 will be like this. Okay, now compare the product and the reactant. So which of the product, green or the red one, is similar to the reactant? If I look at the configuration, what is similar, green or the red one? Which one is similar? According to look at the positions of 1, 2, and 3 and the halogen atom. You can compare halogen with nucleophile, and 1, 2, 3 are same. So tell me which is similar, reactant and green product or the red product?
Green
No one
one?
can. Yes, Hafsa, sorry, green one, right?
Yes, sir. Green product.
Yes, sir.
Green product is similar, right? And that is why we call this as retention. That means this is retaining its original configuration. This green product is its configuration as the reactant. So it is known as retention. So this is retention product, and we will get 50% of retention product. And if you look at the red product, it is inverted, right? It is inverted than the original configuration. So this is known as 50, this is inversion. And we will get 50% inverted product or 50% inversion. And since both of these products will be in the same reaction mixture, this will be in the same reaction mixture and they will be formed in the same solution. That solution is known as racemic mixture. All of you got this? Yes or no? Please tell me. So these are just terms, new terms. Okay, so you can understand retention, inversion, and since they are both in the
Sir,
same
why it
reaction,
is 50% inversion? Sorry, retention. It's actually
because
100, right?
probability, na? No. Probability, na? Half of the
But it's
nucleophile will.
actually the same only, right, sir?
Sorry?
It's almost the same only, right? Only
No,
X
they're,
and X.
they are different. They are different. They are different molecule altogether. We will see this how they are different, but they are different molecule altogether. When the configuration change of a chiral carbon, so they're different. So 50%, this retention is 50% and 50% inversion, and this is known as racemic mixture. And why 50%? So probability. So we have two lobes. So half of the nucleophile will attack from the right side and half of the nucleophile will attack on the left lobe. So 50 is because of the probability, 50-50 chances are there. It looks same. I am not denying that. It looks same for sure, but they are not same right now. Okay, they are not same.
Okay, sir.
And if two things are same, for example, I mean, they are as similar as your two hands. Both of your hands are same, Fia,
Yes, sir.
but they're not exactly same, right?
Yes,
I
sir.
mean, you cannot put a right hand glove on the left hand, or can you?
Yes, sir.
So similar way, what we have to do. So they look similar, and they're exactly like your hand. If you see, they are mirror images also, like your hand, but they are not completely same. Actually, so if you have written this, then write the next product. Write the next point. SN1 occurs via intermediate carbocation. Therefore, rate of SN1 is directly proportional to stability of carbocation. In the next point, SN1 gives 50% inversion and 50% retention product. And the mixture with 50% inversion and 50% retention is called racemic mixture. The process is called racemization. After this, you will write, wait a second. After this, you will write SN2. We are looking at the mechanism now, SN1 mechanism and the SN2 mechanism. We are not looking at the reactions right now. So we are only understanding about the SN1 and SN2. For SN2, you will write, it refers to bimolecular.
Sir, before we wrote a kind of flow chart, like types of SN, they will write this.
No. After you have written this part, arrangement and all, then you will write SN2. It refers to.
Sir, so that part will be empty only.
Which part?
Types of reaction there, SN1, SN2. SN2 we didn't write anything.
No, so even in SN1 we did not write anything. No? Oh, wait a second. Did you write everything like this?
Yes, sir.
कितने में लिख दिया आपने सारा?
Yeah, I wrote it.
And you have vacant space. You have half page
Yeah.
vacant.
Yeah,
So
I
you
have.
write it. So, but you see, I did not write it that way, no? You write it half page वहाँ पे जब आपने लिख लिया था, ठीक है?
Okay, sir.
काफी लंबा था लेकिन आपने अच्छा चलिए कोई बात नहीं. It refers to bimolecular, nucleophilic, substitution. Right? The reaction in which rate depends on both the haloalkene and nucleophile is known as SN2. So in this case, rate is proportional to the concentration of the haloalkene as well as the nucleophile, and that is why you can write rate is equal to K into haloalkene concentration into nucleophile concentration. The order is 2 and the molecularity is also equal to 2. Right, next mechanism. Okay. Second, guys. Please write mechanism. So this occurs in one single step. So we'll write breaking of CX, breaking of carbon halogen bond, and formation of carbon nucleophile bond takes place simultaneously. Takes place simultaneously. Now, in this case, what happens is when you have carbon, and I have three groups, 1, 2, 3. And then I have a halogen atom like this. Okay, I have halogen atom like this. Now, obviously, this halogen atom is pulling electrons, and that is why it is having delta negative, and this carbon atom will be having delta positive charge. Okay. Now comes the nucleophile, and nucleophile is also electron rich with negatively charged. Now nucleophile cannot come and it cannot attack on like carbon atom from here to replace the halogen. Why? Because halogen atom, if it attacks in this order, then halogen atom is also negatively charged, nucleophile is also negatively charged, they will be repelled. They will be always repelled with each other. So what happens? The only way for nucleophile is to attack from the backside. So it will attack from the backside of the carbon. And all of you understood why it cannot attack from the front side? Yes or no? Please tell me.
Yes,
All of you
sir.
got?
As both are negatively charged, so it will cancel out.
No, it will repel each other. Don't repel each other, not cancel out. They will repel each other. So this nucleophile is going to attack from the backside. Attacks on the backside, and how the reaction looks, it is something like this. So please don't write this. First see and then write. So carbon, and then I can write the 1 and 2 group like this. Or I can write the other way around also. I think both are fine. You can have one like this and second carbon atom here, third carbon atom here, the first carbon atom. Sorry, 1, 2, 3 groups are here, here. And then there is a bond formation between nucleophile and carbon. There is a bond breaking between carbon and halogen atom. So I'm showing the formation with blue color. This bond is forming, and this bond is simultaneously being broken. And this is what in the middle it looks like, and this is known as the transition state. This looks like this is transition state. Please don't write now. Let me complete and then you will write. So this is an elegant way of making big square brackets. Okay. So I have to make square. So this is transition state, which is shown always in a transition state. Sorry, which is shown in square bracket. Transition state. And at the end, what's going to happen? The nucleophile is being formed here, carbon atom here, and you have first atom here, the second atom here, 1, 2, and 3 like this. I should show like this. 1, 2, and the third atom, third group is like this. As you can see, it is completely opposite to the reactants configuration. So this is 100% inversion. 100% inversion. So write 2 more points. First is SN2 occurs via transition state. Next point you will write is SN2, or rather you will write in SN2. The nucleophile attacks from backside leading to 100% inversion. All of you got this? Yes or no, please tell me.
Yes, sir.
Okay. Now, after this, in the next class, that is tomorrow, we are going to learn about the factors affecting SN1 and SN2.
Sir, can you scroll up?
How much up?
A little bit more, sir.
tell me the topic. What are you going to write? Which point? Which point?
The diagram, sir.
Okay, this mechanism. Got it? Done.
Yes,
Done
sir.
here. Right? Factors affecting SN1, SN2. We're going to look at 3 factors. Number 1 is nature of substrate. Second is nature of leaving group. Third is effect of solvent. Okay. So this we are going to look at tomorrow. Please write this down. Tomorrow we are going to look at the factors that affect the SN1 and SN2, or rather the rate of SN1, SN2, when the SN1 is going to be faster, when it is going to be slower, and so on.